This is a video from section 3.1 in a Calculus 1 course. This section is on derivatives of polynomials and exponential functions, and we're going to look at some examples from this section. And the directions say differentiate the function. So let's go ahead and write that down. And we'll go ahead and start with example 1. Suppose I had g of t equals 5t plus 4t squared. And I want the derivative. Well, g prime of t, that's the derivative of g of t. Now remember, in this section, you learned that the derivative of t with respect to t is equal to 1, okay? And you also learned that the derivative of t to the n power, now by the way, here you're going to write nt to the n minus 1, and so that's the power rule. Now, the derivative of t is equal to 1, as we've already indicated. So this is 5 times 1, plus 4, and then I'm going to multiply by the derivative of t squared. But by the power rule, you should come up with 2t. Because remember, 2 minus 1 is 1, and so there's basically a hidden exponent of 1 there, okay? And so if we go to simplify, this should be 5 plus 4 times 2 is 8, so you get 8t. And that right there would be the derivative of g of t. And that's how you do example 1. Let's go ahead and take a look at example 2. We'll start using numerical ways to distinguish these examples. So suppose I had f of t is equal to t cubed plus e to the third. Be very careful. E to the third is a constant. Okay? And remember that the derivative with respect to t of a constant is equal to 0. So we have to keep in mind that e to the third is a constant. And so f prime of t is 3t squared plus 0. And so the correct answer here is f prime of t is 3t squared. And so this is an exercise in using the rules of differentiation. Example 3. Suppose I had n of z, it's just the name of a function, and this is equal to z to the negative 5 minus z to the 1/2. So n prime of z is negative 5z to the negative 6, right? Because negative 5 minus 1 is negative 6. And then I'm going to subtract 1/2 z to the negative 1/2. And if your instructor doesn't like negative exponents, you can say that n prime of z is negative 5 over z to the 6 minus 1 over 2z to the 1/2. And that's how you would find the derivative of n of z. Example 4. Suppose I had v of t is t to the negative 3 over 5 plus t to the 4th. So if I take the derivative of v, I have to take the derivative of each of the terms. So that's negative 3/5 t to the negative 3 over 5 minus 1, right? So we bring the negative 3/5 out in front and we subtract 1 off the exponent. And then we're going to add 4t to the third, right? 4 minus 1 is 3. And so this is negative 3 over 5 t. Now negative 3/5 minus 1 is negative 8/5. So I'm going to put a negative 8/5 up on top there. And then I'm going to add 4t to the third. And so therefore, v prime of t, if we don't like negative exponents, we have to write this as negative 3 over 5t to the 8/5 plus 4t to the third. And also keep in mind, your instructor may want you to get a common denominator on this one. Okay? So in next chapter, it will be important for you to be able to do that. Example 5. Suppose I had h of w is square root of 2w minus the square root of 2. Now remember, the derivative of a constant is 0, and the derivative of w is going to be 1. And so h prime of w is square root of 2, but I'm going to multiply by 1, and then I'm going to subtract 0. So remember that square root of 2 goes along for the ride. We pull that out and take the derivative of w, which is exactly what we did. And so h prime of w is just square root of 2. And that's example 5. If we come over here to example 6, suppose I had w of t is square root of t minus 2e to the t. So w prime of t is, well, if we write it this way, this might help you guys. You can write square root of t as t to the half, and then you subtract 2e to the t. And so I will pull the 1/2 out in front and multiply by t to the 1/2 minus 1. And then I'm going to subtract 2 times, and the derivative of e to the t is e to the t. Okay? And do you notice how I say w prime of t? You don't just want to write equals. You want to say that you're taking the derivative. So if we go to finish out this example, we have w prime of t is 1/2 t to the negative 1/2 minus 2e to the t. And if we don't like negative exponents, we're going to say w prime of t is 1 over 2t to the 1/2 minus 2e to the t. And that's how you would do, and this is example 6. Let's take a look at example 7. So we'll work 4 examples additionally in this section. Suppose I had the following. F of t is 2t minus 3 to the second. So we don't know how to deal with this type of question just yet, but what we do know is how to square that out. And so we have to simplify f a little bit. So we have 2t minus 3 times 2t minus 3. So if I square that out, I get 4t squared minus 12t plus 9. Now I could take the derivative of that third line. Okay? And so what I'm going to say here is f prime of t is 4 and I'm going to multiply by the derivative of t squared, but the derivative of t squared is 2t. And I'm going to subtract 12, and I'm going to multiply by the derivative of t. The derivative of t is 1, and then I add 0. So if I go to simplify, I get the following. F prime of t, so let's go back. 4 times 2 is 8, right? So I get 8t minus 12. And that's example 7. Let's take a look at example 8. Example 8, we have k of r is e to the r. Okay, this one's interesting. So it's e to the r plus r to the e. This one's tricky, and you have to be careful here. Now, what we learned was d dx of e to the x is equal to e to the x. But instead of an x, we have an r, but the principle still remains. So if I take the derivative with respect to r of e to the r, I claim you're going to get e to the r. So the derivative of e to the r is e to the r. Now, on this second term, we're applying the power rule. So I'm going to pull the e out in front, and I'm going to multiply by r e raised to the e minus 1. So it's e to the r, the derivative is e to the r plus e times r raised to the e minus 1. And that right there is how you do example 8. Okay, so let's look at 2 more examples. We're going to look at example 9. Suppose I had the following. This one's a good one. So f of v is the cube root of v minus 2v e to the v divided by v. So I'm going to split off this fraction. So we don't have any set rules just yet, but we do know how to simplify this function. So I have cube root of v over v minus 2v e to the v divided by v. But this is v to the 1/3 over v to the 1st minus the v's go, and you have 2e to the v, which is v to the negative 2/3 minus 2e to the v. Now, from here, we could take the derivative comfortably. So if we go back, I'm going to go f prime of v is negative 2/3 v, and it's going to be negative 2/3 minus 1 for the exponent. Negative 2/3 minus 1, okay? And then I'm going to subtract 2 times the derivative of e to the v, which is e to the v. So it'll look like that. And so f prime of v is negative 2/3 v to the negative 5/3 minus 2e to the v. But if your instructor doesn't like it, negative exponents, you can write it this way. F prime of v is negative 2 over 3v to the 5/3 minus 2e to the v. And that would be example 9. Let's do one more example for this video. We'll do example 10. Suppose y equals e to the x plus 1 plus 1. So if I take the derivative, well, let's write it this way first. E to the x plus 1 is e to the x times e to the first. That's a constant, plus 1. But remember that we know the derivative of e to the x. The derivative of e to the x is e to the x. So I'm going to write this as e to the first times e to the x. And then the derivative of a constant is 0. So I'm going to write plus 0. But if we simplify this, y prime is going to be e to the x plus 1, and that's it. Now, it turns out, and this is a really interesting rule, that if you take the derivative of e to the x plus k, I claim that's going to be e to the x plus k, where k is constant. And that concludes this video for section 3.1 in a Calculus 1 course, and we worked through 10 examples. Thank you.